Graph the solution set to the absolute value of 2x minus 3 is greater than or equal to 5 and express it in interval notation. Again, we're going to start by solving the corresponding equation. So we're going to write this as the absolute value of 2x minus 3 is equal to 5. And we're going to solve this because this is going to give us the endpoints of the intervals in our solution. So to solve this, we need to split it up into 2x minus 3 equals 5, or 2x minus 3 equals negative 5. And we need to solve each of these equations on their own. For the first one, we can add 3 to both sides to get the 2x alone, giving us 2x equals 8. And when we divide by 2, that gives us x equals 4. And then for the other one, we can add 3 to both sides to get the 2x alone. This gives us 2x equals negative 2. And when we divide by 2, that gives us x equals negative 1. So here the solutions we get are x equals 4 and x equals negative 1. So we will have to plot those on the number line. Now this time, because our inequality says that we're allowed to be equal to 5, it's not just greater than, but it's greater than or equal to, that means that we're going to be using closed circles at these points. So we're going to put a closed circle at 4 and a closed circle at negative 1. And then because the absolute value can be greater than or equal to 5, that means that we're looking for larger distances, and so that means we are shading the outer portion. So we've got to shade outside of these points. So this ends up being the solution set on the number line. Now we want to write this in interval notation, and we've seen before that when we have two separate intervals for our solution, we write the union symbol in between them. So our first interval is going to be negative infinity, comma, negative 1, and then bracket, and then the union symbol, and then bracket 4, comma, infinity. Remember, when we have two intervals, like with the or inequalities that we saw before, we will have both of those in interval notation and then the union symbol in between them. And this ends up being our final answer.